So this is actually, how many of you watch South Park? Okay, a few of you.
What are you going to do to us?
What is this? What's going on?
You agreed to the iTunes terms and conditions too?
What?
I just clicked agree. I didn't read it. I was in a hurry, you see, and I didn't know what I was agreeing to.
I can't even read English. Hey, shut up in there. You all agreed to stay quiet.
Hey, let me out of here. This is a mistake. I agree by accident.
You can't agree by accident. There's a fail-safe built in. Even if you click on agree, another little window pops up that says, are you sure you agree? And you have to click on agree again.
What are you going to do to us?
Everything that you agreed to in the iTunes conditions.
We didn't read them.
Yeah, right. Who just agrees to something they don't read?
Okay? So, I think we're all feeling very guilty inside. Even myself as well. When I was looking at this episode, I realized that they are talking about me. And there's a fail-safe, and I still click OK. Never mind, that's okay. I want to get the thing, right? And is there a better way to do this kind of contracts? You know, in the 1990s, the insurance industry, they did this thing known as the insurance in plain English. So, our grandfather, when they buy insurance, wow, they are past a dictionary, right, with so many words, right? And it's all legalese, and you don't understand, wow, you get a headache to read it. Then after that, in 1990s, in order to, because more competition, they want to sell better, they start to introduce the legal terms in plain English, but yet it still protects both parties pretty well. Can we learn from this? If there are regulators here in this crowd, I would really like you to go back and champion this. Yeah, you can also get a lot of brownie points if you do that. There's also the part about, you know, what if the pub get bankrupt? You'll never know, right? Barings Bank can get bankrupt. Lehman Brothers can also get bankrupt. Can Google get bankrupt? So how? Do you want to have multiple card accounts and then you email all the things around each other? Or how do you do that? Is there any disaster recovery? Or what if they accidentally? So there was one day when 150,000 Gmail accounts were reset. Imagine you're a Google account user for 7 years, and then all your emails just go stop. When you wake up, you log in, oh, nothing. There's no welcome message somewhere. Welcome to Gmail. How? What can you do? Nothing, right? So, security is not just about being very hard or very, wow, I better firewall, It's not about this. It's about awareness. Awareness that your data is in the hands of someone else. How do they actually do it? How do they protect you in return and give them something? There's also the thing about data ownership. So for certain things that I do, I create fake accounts. Okay? So that they don't spam me. For example, this is one of my fake accounts I have a few. When we log in, so you can see what I'm trying to do. When we log in, we realize that there's advertisements there. Wow, I have an email about Batam. Then suddenly all the Batam deals all appear at the site. How did that happen? Anyone know? How? They scan. Right? They scan your messages. Wow, scary, right? When you say, dear, I love you, I enjoyed my time with you in Batam. And all these are actually inside, and then they scan every word. And that's how they generate advertisements. Okay? But that's not all. They make money from scanning your information because they sell the advertising space. right? But do you get any money in return? Don't say asset. Do you get money in return? No, right? Why? Because it's free. You agreed to it. You already agreed to it when you sign up for it. So how? Quiz. So if you look at the asterisk just now, the first question, just raise your hand, okay? And then come forward, and then say a vote. No, I won't get your personal data, don't worry. Name two. There are a lot of new, challenging, interesting areas. I'll go through some of them so that you can take home, and you can tell your wife, I really went to National Library today. Okay? So this is a picture, very nice, right? It's actually the internet, the connections that are between the different nodes, the different computers, being visualized out in the form of a visualization of a network graph. Fantastic, very nice, but very complex, right? How? And you think about it, what is cloud computing trying to do? We are trying to actually do what? Make life easier, alright? We're trying to make life easier for ourselves. So, do you think the cloud computing efforts will die? Not really, right? We are already using it. Like it or not, we are already using it. Do you think it will die? No, we wouldn't. But we are imagining ourselves using it. But there's a different group of people who like to use it too. And these are the hackers. So now they can buy the same service either for free, okay, or for very cheap, and they can actually go and hack your wireless router right now using their account. And they use the very same internet connection to hack you. And it is used to be thought like, oh, this so many, wow, so just now we try to crack the, please give me my free book, right? Oh, it's just so short, right? And then we have really complex and very bad formulae. So it's massaged many million times. Okay? But wow, what used to be thought to be unconceivable, now is a reality. Because now with cloud computing's computational power, we can easily break all this. You just see how much money you want to spend. Okay? And you can hack something. And that's how scary it is. But we look at it, it's not about security anymore, right? It's about, now we more or less give up. Okay, all the copyright, yes. Okay? Security all handled by them. But the other thing is whether I trust you or not, whether I like your face or not, right? Whether I trust them to take care of my data. And it comes to this thing where we have to protect the data. When you see the Julius Caesar example, you see that they are doing protection. They are protecting the data. Okay? They are protecting the data so that no one can read it. Okay, and no one can use it in any way. Now, okay, with cloud computing, there is a need to both protect the data and to use it. Wow. How? Very hard, right? Cracking the Julius Caesar cipher is really so hard. How can we even do the both using it? So imagine, okay, you are now able to securely jumble up your bank account number, put it into a large cloud, and they still can process and identify this is your bank account number without knowing what is the number. Maybe your number is 1, 2, 3, 4, okay? And you put it inside and become okay? So from the they still know that it's your bank account. Wow, so intelligent. Right? How? Is it possible? Yes, it is. And it's the job of researchers to actually look at it, to operate on the data while they are encrypted. So let me share with you one thing that you can prove to your wife. Okay? This is known as the partially homomorphic encryption. Why? Why is this important? Let's look at this example. When you do two numbers, 10 plus 20 is 30, right? Typically, we are not able to do this right now, which is something blah 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 plus blah 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 equals to this, which eventually decreases to 30. Wow, amazing, right? So you stop the plus operation, which is very crucial in encryption. Okay, the next one, multiplication. And even though we know it's gibberish, we still give you gibberish, but the gibberish can be decrypted to 10 times 20, which is 200. Oh, amazing. And it's done efficiently now. But there's a problem. We can't do that together yet, efficiently. So the holy grail is fully homomorphic. So just now was partially homomorphic encryption. Now we are aiming to do both, multiply and the addition together. And it's achieved, theoretically achieved. In 2009, some smart guy called Craig Gentry, okay, from IBM Watson, our competitors, okay, solved this problem. And the drawback is to process 1 byte, it takes 15 minutes. Okay, nowadays our hard disk is how many bytes? How many terabytes? Right? So theoretically he has solved it, but we believe in the near future we will be able to do that. And once we can do that, we can dump all our encrypted data into the cloud. And the banks or the people who are the third-party people who are handling the data, they just know how to process it, but they do not know the exact information. So when he sends me the SMS, I recognize the gibberish that he sends me, and I give him the free book. I no longer know his telephone number. That's amazing, right? Yeah. And why do I talk about plus or multiply and not minus, right? So why? Because they are used in statistics. They are used in the basic operations that we do. They are used in handling all the different kinds of calculations that we have based on. And with this, right, we can now even have banking clouds, which is unimaginable now. And I will now consult the cloud again to show you the example, okay, of our competitors, but it's okay. I believe that good knowledge has to be shared. And I think you should deserve to know this too.
Security is in many ways an arms race. It's an arms race between the good guys and the bad guys.
We all know what security is in the internet, and the underlying mathematical basis for the security in the internet is in fact cryptography. Any time that you go to your computer and you interact with the world, you're using crypto. So you're asking me how widespread it is, I would say it's everywhere. The most common unknown component of crypto is probably encryption, which was made popularized in such books as the Da Vinci Code and so on, so everybody knows what encryption is. So encryption exists throughout the ages, of course, was a big part in World War II. At the end, the U.S. winning the war was also part of breaking the German code. Encryption is the process of taking clear data and turning it into a ciphertext, which basically means something that is not understandable. The reverse side of it is decryption, which is the process of extracting the data out of the ciphertext. For example, when you send your credit card across the internet, you want it to be secure. You want nobody to see your credit card number, but you don't even know that you're using crypto to transfer your credit card from one end to the other in a secure fashion.
Many of the technologies that we develop are engineered or targeted to address a societal need for security and or privacy. So we either see a problem in the making or we anticipate that a problem might arise, and we try to address these problems by developing and standardizing and productizing some of these technologies.
We have a crypto group here at IBM, which includes 7 people, including me, and I'm the manager of the group. We are involved in all aspects of cryptography.
This is Shai Halevi and Chanjit Jutla.
This is Hugo Grafci, and he's the designer of very important protocols which we all use. This is Rosario Gennaro, who's another member of our group. This is Vinod, and Vinod is a postdoc here in the group, so he's here for 2 years. And the last person to join our group is Craig Gentry, whom I told you about, who developed the homomorphic encryption.
This is the guy who did the fully homomorphic.
So basically the idea of a homomorphic encryption scheme is that you can sort of operate on messages while they're encrypted.
Some of the schemes that we come up with, like homomorphic encryption, for example, increase the security and privacy of customer or consumer data in a cloud setting.
The homomorphic encryption has the property that even though you've taken this data and you've encrypted it and sort of made it into junk, seemingly junk, you can still compute things on the underlying information that would enable you to do operations while still preserving the privacy of the data. And this is a problem which has been open for 30 years, and it was sort of a holy grail. The homomorphic encryption is a huge theoretical breakthrough, and it shows that we can actually achieve homomorphic encryption. But it should be remembered that this current result is a proof of possibility, that in order for it to be available tomorrow in the market, still a lot of work needs to be done. If it's not going to be in the market tomorrow, it's going to take some more time. But it doesn't take away anything from the greatness of the breakthrough.
Every time that one has a service or some asset of some value, one needs certainly to protect it, despite the best measures taken at that point in time. That the bad guys are likely to raise the ante or up the ante.
Even in the current situation, it's like Cox and Roberts games. I mean, the hackers are attacking us, we defend. Attack, defend, attack, defend.
My goal is to protect against all these weird, very powerful, very malicious attackers.
As newer forms of attack become more common, that we have to respond with more sophisticated countermeasures. And we have to proactively implement these, and again, from our side, raise the stakes in the game.
Isn't it funny that only a smart kid gets access to Steam?
So our day-to-day in the group is, as I said, we're very close-knit. We've known each other for a long, long time, and we're actually also friends. So, for example, lunch together is a must. Then we discuss any topic that you want.
So in case it's an official game, verify the alphabet.
Sometimes it's encrypted because some of us speak foreign languages, so it's somewhat of an encryption.
I am delighted to have this job. I think I have one of the greatest jobs in the world, to have a ringside seat, if you will, in terms of working with academia, with government, with IBM business units, and with IBM customers. I think that's a very wholesome and fulfilling experience.
It's nice to go to sleep thinking that you saw something really good.
I love it. I mean, it's become part of my life. Also the love for the subject, but also it has to do also with the environment that you're in.
Right. So we learned that the guy is probably the most eligible bachelor for the young ladies. He's going to be, I think, going to be, if not as famous as Einstein, because of the dependence on computing devices. Because he cracked something that is going to be useful for at least the next 100 years. It's amazing, really. So the next thing that I want to discuss about is something to do with trust. Okay? Recently, in 2011, June, if you use Dropbox, how many of you use Dropbox here? Well, quite a few. Huh? So there was actually a time when, for 4 hours, your Dropbox account, you don't need a password to go in. Right? What does that mean? It means that your subordinate can go into your Dropbox account and see all your files, or you can go and see your boss's file, or you can see whether your husband has a mistress file. Right? And what does that mean? It means that it attacks our trust in cloud computing providers. It also exposes the need, right, to increase trust. When we have issues such as this, we need to understand that we're not alone. In fact, 88% of those who are surveyed, okay, actually wants to know what actually goes on. You know, the Dropbox thing, right? The password free for all. You know how long it took for them to find out? It only took just 15 minutes. Okay? If I don't remember wrongly, I think 5 or 15 minutes. And they found a problem. But for the whole problem to be solved, it took 4 hours. Because of the scale of the problem. Okay? So, there are many ways to mitigate this. And conceptually, we at HP Labs, we think about this problem a lot. We talk about, okay, we have seen all these things, but we found that the bottom two, accountability and auditability, is quite rarely tackled. And we are very happy because we found our home. We managed to do another project that we are able to do it. We built service over it. It's one of the projects that I'm leading. In fact, one of my associate members here. And nope, not this. And let me just show you a simple demo of what we can do. So every little data transfer, every little file movement in the cloud, now we know it. We track it and we keep its history. And the history is known as provenance. Okay? And now with this thing, we can track the provenance. So we're showing this case where Alice, who is actually my intern, we got her to doll up one day and dressed in the nice yellow dress for this video. She's creating a file in cloud. And all these sections, the creating, the writing, at what time, by who, and where. Not only in the virtual machine, but also in the physical environment. So we know exactly which country it is in. And then, in which country it is in is very important because there are some rules which actually say that, you know, you can't transfer your data out of this country because of the Banking Secrecy Act. This is a very important problem. So we created a demo to show this. Of course, before that we really patented it. But now we're showing you the possibility that you can even label your programs file. Label them, say, no, this is a sensitive file, and you keep track of it. Keep track of it for me. You build an app over it, keep track. And even label whether this is a sensitive document, whether this is a restricted document. And then a boss, you know, being bosses, they want to know what their staff are doing. So the boss came in and assessed the file, fellow researcher. And he accesses the file and every action there is being recorded. And right now, because everything is being recorded, we have transparency of all the data movements in the cloud. We know what actually went on. We have a criminal scene investigation kind of evidence, forensic evidence, to show that something really went wrong. This is not lacking in the current cloud providers. So for example, when Alice returns from a break, she realizes, aha! There's this file that is being flagged as red and it's being touched by someone else. And who did it? It was Bob. And you can see even the time and who, at what time. Was it a green action? Was it a red action? And so on. And the other files are seen to be, you know, okay. The other files are green. And she says, okay, that's my boss. I think it's no problem. All I need to do is just label that as probably authorize him as one of the people who can touch the file from now on. And he will be tracked. And this was done. And this list, right, is actually extracted from the cloud. We don't keep it in the machine. I'm currently leading, and we can build many different possibilities over this. Okay? Forensics as a service, or even track suspicious activities. For example, Al Qaeda. You know how they pass information to one another? They don't send email. They create a Gmail account. They create a draft, and then they save the draft. Then the next guy log in from another side of the world with the same password, open the draft, read the draft, add on to the draft, or change the draft, and save again. Can your network sniffing detect that? Okay? And there's also this trend towards mobile devices. Laptops and desktops are now called grandpa boxes, sadly. But we still have a lot of things to do to actually secure them. But what's interesting is all of you here must be aware of this trend. On the bottom, the light blue area, you will notice that that is actually representing the laptop sales. And it's actually dropping. And it's forecasted to drop and continue to drop. And you realize that the tablet or netbooks are increasing over time. And what's more alarming is that at 2015, the tablets will be 23% over 18%. It means it's surpassed. And this is our reduce in dependency in the local machine, increase in dependency in the cloud or in the internet. And the law must catch up. In technology, there are two gatekeepers. Okay? The people who make the law and manage the law, and there's also people who create the technology. The people who create the technology have to be regulated by the people who create the law. And in Singapore, we will be having the data protection law, which is fantastic because right now we are empowered by this. And this allows cloud service providers to have a due diligence to protect our data properly, right? So the concerns that we had just now are probably going to be addressed here. I hope. I haven't seen it. And the other thing we notice is security education is also very important. We now have this thing like click checking, which is hijacking via a click, where they give you very seductive pictures and you expect to see more, and then you click on it, and then you make a mistake of your life. Okay? All phishing, which is not new to everyone. But moving further into the future, we realize that young people will have the skills to be a script kiddie. Script kiddie means those who can download the right tools to do hacking on other people. They don't know any programming. They just know how to download and use it. It's very scary. Okay? And if you have a child, and your child doesn't know what he or she wants to do, it's probably a very good bet to encourage them to do IT security in the future. And remember, data is an asset. And it's pretty much the only thing left for us to protect over the years. And like it or not, we will all be part of this movement. And what have we learned today? We appreciate what we have all about cloud computing. We understand that the data is the most important asset. We also looked at several key areas of cloud security and the challenges ahead. Most importantly, we learned from the past how people protect data. We understand the limitations right now, and eventually we prepare for the future. So that's all for my talk. Thank you very much.
Thank you, Ryan, for the enlightening talk. Of course, we'll have 5 minutes or so for Q&A. I have a first question. Anyone?
So while waiting for the question, I will quickly sprint through the words from the sponsors. I'm wearing 2 hats. I'm from HP Labs and Cloud Security Alliance. In fact, some of the Cloud Security Alliance guys are here, like, for example, Sunny and even Don. Yeah. I'm not sure whether Bruce is a member. Not yet. So you guys can also be a part of this and join in the effort. Okay? And But to begin, you know what we want to do? You can start Googling these two great documents, which I actually referenced from. So in the talk just now, I used very layman English to explain a lot of technical jargon which I hate listening to. So the first one is top threats to cloud computing. It's a very good document. It tells you how to be aware of this thing. Okay? Anytime that you want to have a question, you can raise. I'm just spending the last 5 minutes productively. And yes.
You mentioned this now about
yes.
especially the resident is there a good distinction between using a laptop versus
At the moment, no. But there is a key difference is the transmission methodology. Most of the mobile devices can still also go through the telco, through the 3G network. And that's yet another